In the last session, we introduced the topic of hydrocarbons and specifically alkanes. Alkanes are hydrocarbons. Again, hydrocarbons can only have hydrogen and carbon. Alkanes are a special group of hydrocarbons in which you have all single bonds. And we started with the simplest ones, and we worked our way up to C4H10. And we showed that for a formula C4H10, you could have two possible ways to draw the structure. You could put the carbons in a straight line, or you could take the carbons and put three in a straight line and then branch a carbon off. And we said that these two different structures with the same formula were called isomers. Again, same formula, in this case C4H10, different structures or arrangements, different bonding pattern. That means they're models of different molecules. Okay, we could fill in all the hydrogens, but I think you know that there would be three hydrogens here, two hydrogens here, two hydrogens on this molecule. There'd be three hydrogens on this carbon. There'd be three hydrogens on this carbon. There'd be three hydrogens on this carbon. There'd only be one hydrogen on this carbon. Okay, so I hope it's pretty obvious to you that these two have different structures. If we were to draw the skeletal structures of these two, okay, the skeleton for this one would be, again, 1, 2, 3, 4, where the end of each line represents a carbon. So 1, 2, 3, 4 carbons. The structure for this one would be, first we'll draw the longest chain, 1, 2, 3, and then branching off that middle carbon is the central carbon. Okay, so there would be the skeletal structure for that one. So looking at the skeleton, it's pretty obvious to tell that these are different structures. Now we have to come up with a way of naming these. So the naming system, we introduced that just a little bit. The naming system is always based upon the longest chain. The first isomer here is pretty easy. The longest chain is 4 carbon atoms. The prefix for 4 is BUT, and we put an A and E ending on there. Again, the ane ending means that it is an alkane, contains only carbon and hydrogen in all single bonds. So the name of this compound is butane. Okay. On the other hand, the name of this compound, the isomer, we look at this one, again, we look for the longest chain. The longest chain is 3, no matter how we count. So its root name is propane. Pro means 3. It has a 1 carbon group attached. We call that a methyl group. We use the HYL ending to indicate that there's a group. The group is attached to the chain. It's attached at position 2. And so we call this 2-methyl propane. And that's the name of that compound. So obviously different compounds have to have different names. Okay, and there we go. That's the naming system. Okay, let's move up to C5H12, the next highest alkane. Again, alkanes fit the formula CnH2n plus 2. It's a really handy relationship to memorize. The relationship between carbon and the maximum number of hydrogen atoms. So if we go to C5H12, the first structure we're going to draw is the one where all 5 carbons are in a straight line. 1, 2, 3, 4, 5. Again, we won't show all the hydrogens. We could do the condensed structure. Condensed structure would be CH3, CH2, 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 CH3. So there are our 12 carbons. The skeletal structure would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this molecule would be called pentane. Again, ane, all single bonds. Pent, for the fact that it has 5 carbons. Well, we pop 1 carbon off the chain, and now we've got a 4-member chain. And now we've got to figure out where we can place that 1 more carbon so we can branch 1 carbon off here. And we would call, again, this would have a condensed formula of CH3, CH2. We now get to this carbon. This carbon has a hydrogen attached, plus it has a methyl group attached. So the CH3 in parentheses refers to the branch. and followed by CH3. So there's the condensed formula for that one. The skeletal structure, longest chain is 4, 1, 2, 3, 4, and branching off of that carbon, we have a 1 carbon group. Okay, this compound is named, well, let's take a look. The longest chain is 4, so it's going to be butane. Again, we work from right to left is the root. So the longest chain is 4. Now, be a little careful here. We've got a 1 carbon branch called a methyl group attached to the chain, and it's attached at what position? Well, if we count from left to right, 1, 2, 3, 4, it looks like it's detached at position 3. If we count right to left, 1, 2, 3, 4, it's connected to the 2 position. Rule is we always want to count to get the lowest number, so we're going to count, in this case, from right to left, and say that carbon is connected at position 2, and this is 2-methyl butane. 2-methyl butane. Great. There would be no 3-methyl butane, because I hope you can see that if we had a carbon connected at position 3, it would really be the same as a carbon connected at position 2. So this is the only isomer that has a 4-member chain. So the next thing we do is we come along and say, well, what if I put 3 in a row? 1, 2, 3. What could I do with those 2 separate carbons? Well, I could put 1 here and 1 here. And when I do that, I look at that and I say, that's a different structure. The condensed structure for this would be CH3. Careful here. Carbon in the middle here has 2 CH3 groups attached to it, so we'll put that in parentheses to represent the group. We'll put a 2 outside the parentheses to say that there are 2 groups, and then finally we go to this carbon, CH3. So there's the condensed structure showing the branches. Finally, the skeletal structure. Longest chain is going to be 3, 1, 2, 3, and we've got 2 carbon branches coming off that center carbon. So there is the skeleton of that one. Now, how do we name that? Well, the longest chain is 3, so again, starting from right to left, propane, pro meaning 3 is the longest chain. We've got 2 methyl groups attached, okay? So we're going to call this dimethyl. We use the di to indicate that there are 2 separate methyl groups, dimethyl propane. And then finally, to finish it up, both methyl groups are attached to the second carbon. So we call this 2,2 dimethyl propane. And those are all of the isomers for C5H12. So we have 1, 2, 3 different isomers for C5H12. Okay. You might imagine we'll go up to C6H14, and you won't be surprised that we'll run across a number more isomers. So again, 6 in a row is the simplest structure, and we all know that's called hexane. Condensed structure, CH3, CH2, 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 CH3. We can condense this just a little further if we want. CH3, CH2, 4, CH3. We can take all of these CH2s in the middle and condense those down further. And then the skeleton, 6 carbons in a row. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's our skeleton structure of hexane. Good. It's the simplest isomer. Now we just start playing the game. We say, okay, well, let's go with a 5 chain. And in my case, I like to keep the chain perfectly horizontal. And then let's put a branch. We'll put a branch here. That's a different structure. Its condensed structure is CH3, CH2, CH2, CH, CH3, CH3. I hope that makes sense to you. Its skeletal structure has a 5 chain. 1, 2, 3, 4, 5. And coming off the second carbon, we have a branch. So there's the skeletal structure. Okay. How do we name this? Well, the longest chain is 5, so its root is pentane. we've got a 1-carbon branch, so it's methyl pentane. Okay, that's our methyl group. The methyl group is attached at the 2nd carbon. Again, numbering from right to left puts it at the 2nd carbon, so it's 2-methylpentane. Okay? Well, look closely at that. We can go to another possibility. Again, we put 4 carbons in a row. Excuse me, 5 carbons in a row. And now we'll take that 1-carbon branch and we'll put it off the middle carbon. I won't do the condensed or structural or skeletal formula here. You probably can do those on your own. What we're really focusing in here on is the naming. And again, this is going to be pentane. We still have a methyl group, so it's methylpentane. And the last piece of information we have to get is what carbon it's attached to. It's 3-methylpentane. Again, that methyl group is attached at the middle carbon, carbon number 3. Now, those are the only 2 methylpentanes. Obviously, if we tried to do 4-methylpentane, we would discover that 4-methylpentane was the same as 2-methylpentane. And so those are all the methylpentanes. So we'll play the game again. We drop off another carbon. So now we start with a 4-member chain. And now we have 2 groups to play with. So maybe we'll put the groups on the same carbon. All right. Again, we're going to name that as what? Looking for the longest chain. Longest chain is 4. So its root is going to be butane. It has 2 methyl groups. We saw that before up above. So it's going to be a dimethyl. Butane. And then we have to tell the positions. 2, 2 dimethyl butane. The 2 methyl groups are attached to the same carbon. Let's look at another isomer. Again, these are all isomers. They all have the same formula but different structures. Instead of attaching the 2 carbons to the same carbon, we could take the 2 methyl groups and attach them to separate carbons. That's a different structure. And the only change in the name here, it still is a dimethyl butane. Again, butane is the longest chain, but now the carbons are at position 2 and 3, so we call this 2,3-dimethyl butane. Well, let's finish it up here. I think we've exhausted all the possibilities for 4 carbon chains, so how about a 3-carbon chain? Is that going to do anything? 1, 2, 3. Well, we've got now 3 carbons to play with. And what we discover is that, well, we might try this. Put a carbon here, maybe put a 2-carbon group here, and a 1-carbon group here. But what we suddenly realize is that has a 4 chain. So we've already seen that one. This one is the same as that one. We play around a few other times, and we realize that there really is no way to work with a 3-member chain without creating something we've already created before. So we have all of the isomers for C6H14. We had one here. We had a second one here. We had a third one here. We had a fourth here. And we had a fifth here. So with the formula C6H14, there are 5 isomers. Remember, isomers are same structure, same formula, C6H14 in this case, different structures. All right, we reviewed, we also introduced the naming system, yeah, we'll have another video after this to look at a few more complicated examples. All right, maybe you would want to try C7H16. Let's see how many isomers you come up with, naming each one of them.